So we need to resolve the given rational fraction into its constituent partial fraction. Let us begin. So we have here our rational function 4x divided by, we have the factor x plus 1, which is repeating twice, and this is multiplied to another factor x minus 1, which is also repeating twice. That means in a total of 4 factors. So let us suppose that this can be broken down into 4 partial fractions, with the first one being a over x plus 1, followed by the second partial fraction, which is b over x plus 1 whole square. Then we have the third partial fraction, which will be c over x minus 1, and the fourth partial fraction will be d over x minus 1 whole square. We're going to label this as equation number 1. Our goal will be to find out the value of the constants a, b, c, and d. Now there is a method known as the cover-up method, which can be used to find out the value of the constants b and d easily. However, we cannot use that method to find out a and c. That will become apparent in a moment. So let's use the cover-up method. Using the cover-up method, the value of b will be equals to, we'll have to consider our original rational fraction, and in the denominator we have to cover up the factor x plus 1 whole square, which means we are now left with x minus 1 whole square. What we have done here, we have covered up the factor x plus 1 whole square. So if we consider x plus 1 whole square and equate it to 0, solving for the value of x, we get x equals to negative 1. Substitute this into our original equation, and our b value is going to be equals to negative 1. Similarly, we can also find out the value of d. The d will be equals to, consider the original rational fraction 4x, and this time in the denominator we're going to cover up x minus 1 whole square. So we get x plus 1 whole square. What we have done here, we have covered up the value x minus 1 whole square. So if we equate it to 0 and solving for x, we get x equals to 1. Substitute this back into original equation. We're going to get the value of d, which will be equals to positive 1. Now that we have obtained the value of b and d, what about the values of a and c? We can't use the cover-up method to find out the values of a and c. That's because, let's say, we use the cover-up method to find out the value of a. Now that means a comes out to be 4x divided by, so look at the factor of a, so that's x plus 1. So we have to cover up x plus 1, meaning we still are left with 1x plus 1 in the denominator. This will get multiplied to x minus 1 whole square. Now to find out the value of a, all we have to do is x plus 1 equals to 0, but we cannot do that because if we make x plus 1 equals to 0, we have a division by 0, which is not allowed. So a cannot be expressed in this particular fashion, and we cannot use the cover-up method to find out the value of a. The same problem arises with c as well. So let's have to go to another method to find out the value of a and c. All we have to do is we will consider equation number 1, and with equation number 1 we're going to multiply it with the denominator, which is x plus 1 whole square times x minus 1 whole square, such that this gives us, we have 4x on the left hand side. On the right hand side we're going to have x plus 1 multiplied to x minus 1 whole square times a. Then our b value will be x minus 1 whole squared times b. The c value will be x plus 1 whole squared multiplied to x minus 1 times c, and the d value will be x plus 1 whole squared multiplied to d. Let's label this as equation number 2. Now clearly equation number 2 is an identity in x. So if we consider a particular value of x, let's take x to be equals to 0, and we already have the value of b and d. So b is negative 1, d is positive 1. If we substitute this back into equation number 2, then equation number 2 is going to give us a minus c equals to 0, or we can say a equals to c. Then we're going to consider another value of x. So let's say if we take x equals to 2, then equation number 2 will then become a plus 3c, that's equals to 0. Now let's call it equation number 3, and this one is equation number 4. So when we solve equation 3 and 4, then we get the value a equals to c equals to 0. Now we have the value of a, b, c, and d, which we can finally replace back in equation number 1, and our final result is then going to be, thus our rational fraction 4x over x plus 1 whole squared times x minus 1 whole squared. So this will become equals to, so we have obtained a as 0, so we don't have to worry about the first term. The second term, b value, which is negative 1, so we have negative 1 divided by x plus 1 whole squared. Then c value is 0. We come to the fourth partial fraction. So that is going to be positive 1 over x minus 1 whole square. So we've successfully resolved the given rational fraction into two partial fractions.